Alright, so this is a lesson on quadratic graphs and their properties. Alright, we're going to start out by looking at this example graph y equals 3x squared plus 6x minus 2. They want us to identify the vertex, axis of symmetry, domain, range, and the number of roots. They also want us to state whether the function is a maximum or a minimum. Alright, so if I look at this, I can automatically tell that it's going to be a minimum. The way that I can tell that is because that is positive. Okay, if it was negative, then the parabola would be going down. But because it's positive, the parabola is going to be going up. I know it's a parabola because it's an x squared. Alright, so let's start out by looking for the axis of symmetry. The axis of symmetry Axis of symmetry is given by the equation x equals negative b over 2a. So in this case, based on this, it's ax squared plus bx plus c. So that would be negative 6 over 3, or sorry, 2 times 3. So 2 times 3. That would end up being negative 1. Okay. 6 over 6 turns into 1, and of course it's negative. The way that I can figure out the vertex algebraically without looking at the graph is to go ahead and substitute in the negative 1 into the equation. Y equals 3x squared plus 6. And then 6 times negative 1 and then minus 2. Go ahead and solve that for y. So if I do this, negative 1 squared is 1 times 3 is 3 plus negative 6 minus 2, which would end up giving us negative, let's see, 3 plus negative 6 is negative 3 minus 2 would be negative 5. Okay, so then my vertex would be the order pair negative 1, negative 5. Alright, so from there what I can do is I can go ahead and make a table and then do a graph. Alright. What I'm going to do is I'm going to use negative 1, negative 5 as a starting point for my table, put that in the middle. And I'm going to go 2 numbers on each side of the negative 1. So I'll go negative 2, negative 3, I'll go 0, and 1. I'm just going to sub those into the equation. 3x squared plus 6x minus 2. So when we substitute in negative 3, we're going to substitute in negative 3 for x, solve for y, negative 2 for x, solve for y, 0, solve for y, and 1 and solve for y. Alright, so let's go ahead and do that. Alright, so when we substitute in, we should have gotten 7 for negative 3, and we should have gotten negative 2 for negative 2. We should have also gotten negative 2 for 0, and we should have gotten 1, 7. And by doing that, that gives us a list of ordered pairs. All right. So at that point, what we're going to do is we're going to go ahead and graph. All right, so let's go ahead and graph those ordered pairs on the graph. Negative 3, 7. Negative 2, negative 2. Right there. Negative 1, negative 5. Right there. 0, negative 2 would be right there, and 1, 7 would be up there. And we draw our parabola that goes through those points. Right, we don't have to draw this part in. I'm just going to put this in here to show that this is our axis of symmetry. But you don't have to draw that in when you're actually working on the problem. Okay, the next couple of things that we're supposed to do is we're supposed to state the domain and range. All right, so let's state the domain and the range. Send that to the back. All right, so let's state the domain and the range. The domain is all real numbers. All right. X could be anything, all right? It's not just the values that we had in the table. It could keep on going. We could choose 1,000,000. We could choose -1,000,000. We could choose any number. All right, the range, the values of the range is a little bit different. All right? All right, this is the lowest value that we're going to have, period. So that means that the y values are never going to go below -5. So we want all the y values that are greater than or equal to -5. Okay, so there's the range. All real numbers was our domain. We already stated earlier that this was going to end up being a minimum. Was there anything else we needed to check? Okay, the last thing we need to do is talk about the number of roots. Okay, so what we need to do first is talk about what are roots. The roots are solutions or zeros. Okay? So when we look at this graph, what we're really looking at is how many times does it cross the x-axis. So we have a solution there, a solution there. So this is going to have 2 roots. Okay. We need to talk about graphs that have no roots. If we have this graph that would have no roots, it would not touch the x-axis at all. And then if we had something that looked like that, that would have 1 root, so it would touch at that 1 point. Right? So that's how we tell the number of roots, and if it was identifiable like the last one was, that ordered that point right there at 1, 2, 3, 4, 5, 0, we would say that the root is at x equals 5. All right, but in the case of our blue one, you can see the graph of the blue parabola. Those roots are not identifiable, so we're not going to worry about listing them out. All right, we could figure them out on the calculator, but we'll talk about that more in a different lesson. All right? So there's a lesson on quadratic graphs and their properties.